When we talk about the shortest path finding algorithms, we refer to Dijkstra's and Bellman-Ford as the most well-known examples of link state and distance vector respectively. In most of the cases, the minimum hop routing becomes the de facto standard implementation. However, as we shall see in this module, there are some inherent limitations which have to be dealt with, otherwise the network performance is degraded. In this module, we shall understand how do we translate shortest path algorithms into minimum hop finding algorithms and what are the disadvantages. The book shown to you here sheds extensive light on the rationale of minimum hop routing protocols and discusses their advantages and disadvantages in a very thorough way. It is highly recommended that you too delve into the theory given in this book and understand for yourselves the issue of minimum hop routing in further detail. The scenario to understand the limitations of minimum hop routing is shown in here. You can see here that we have the senders here and we have the destinations here. We have two possible paths. One is here and the other one is here. Of course, if we look at the shortest path routing from the point of view of X transmitting to Y, we'll see that X takes the path X to A, to B, and to Y. But when we look at W trying to transmit, say, to Z and U to V, they cannot use this path anymore because of the occupancy of the traffic from X to Y. So, in that case, this part of the network becomes unusable to them. This inherent limitation of minimum hop routing can be understood by the fact that the shortest path routing is the minimum hop routing as we are considering the weight of each edge or link equal to 1. Of course, minimum hop routing comes with some inherent advantages. That is, if the total bandwidth on a route is d times h, and if we are able to find the shortest path minimum hop count path as h min, it takes the minimum resources. The resource consumption for this routing activity is the least. But that's the obvious advantage at the cost of one observation. That is, consider that X uses A and B to reach Y. It results in non-utilization of direct hops. The other sources that I mentioned in the figure would never use these resources, and hence the network gets partitioned. This is one of the natural limitations of minimum hop routing. Various strategies exist that we shall understand in due course, which try to prevent this disadvantage from becoming overwhelming.